Please join me in welcoming Sarah Sondag with Minnesota DOT.
I'm going to talk a little bit about MnDOT's bridge maintenance performance measures. And before I get into the whole performance measure thing, I'm going to give a little bit of background on Minnesota bridges, also background on how we identify and track maintenance, and then get into a little bit of some of our definitions surrounding different types of maintenance. MnDOT owns approximately 5,000 bridges out of the 21,000 total, and we define a bridge as 10 feet or greater. The remaining 16,000 are owned by over 200 local agencies. MnDOT is broken into 8 distinct districts with 20 bridge maintenance crews. We are a decentralized state, so the districts perform inspection and maintenance on the structures that they own. Needs are identified through different processes, through inspections and maintenance assessments, but also through different types of condition data and preventive maintenance schedules for those recurring activities. The majority of the maintenance is performed by in-house crews, but we do have maintenance that is also performed by contract. And typically that contract maintenance is performed on bridges that may have challenges due to access or high traffic volumes, or perhaps to supplement in a high workload time. Maintenance needs are tracked in our SIMS maintenance module, and that's through Bentley AssetWise. Accomplishments are documented in SIMS and in our timesheet system. Costs are tied together then with our financial system through an analysis tool called Oracle Business Intelligence. This is a screenshot of our maintenance module form. I know it's kind of small, I apologize for that, but we did add kind of a fully configured maintenance module within SIMS, and that helps us with planning, with scheduling, prioritizing work, and also with tracking and documenting accomplishments that can help us with tracking also performance measures. Maintenance tasks are tracked by the bridge number, but also by the crew and the district that performs the work, and tied to an activity code so that we can tie that and link that back to our costs in our timesheet and financial system. They're also tied to an element, and that helps us bring that task back to that initial deficiency that was found so we can close that loop. It also provides an opportunity to identify benefit associated with that task. Each maintenance activity is then assigned a designation of either preventive or reactive maintenance within the SIMS maintenance module, and those fall under that broader definition of preservation. We define preventive maintenance as those routine activities that are performed according to an assigned frequency or as needed, really to slow that deterioration down. Reactive maintenance then is scheduled in response to an identified condition. Reactive maintenance is then further divided into a priority level. High priority maintenance is in response to conditions that may impair safe function or deteriorate to critical if not repaired within 1 year. Medium priority reactive maintenance are response to conditions that are expected to deteriorate within 3 years, so need to be repaired within that 3-year window so they don't deteriorate to a higher priority level. And low priority reactive maintenance is in response to conditions that have no impact on structural function or user safety and may be deferred past that 3-year window. Talk a little bit about performance measures. They're typically established to manage performance. Traditionally, they focus on condition, typically percent of deck area in good condition or percent in poor condition. But they're also managed to reflect investment strategies aimed at achieving state of good repair. And performing that preventive and reactive maintenance is to keep those bridges in good condition. So it makes sense that we would look at performance measures on these bridge maintenance tasks. As I mentioned previously, reactive maintenance is in response to an identified condition. We have 3 performance measures for reactive maintenance. 2 of them are still in the development phase. They're divided by the priority levels. So for high priority reactive maintenance, we look at the percent completed on time or within that 1 year of identification. The target is 99%. We do report that annually, internally. Medium and low priority is based on reduction of backlog, and we're still working on the targets for that piece. Possible future measures could include looking at deficiencies that cause accelerated deterioration if they're not repaired, so things like potentially drainage systems that are not repaired in a timely manner. For preventive maintenance, again, those are activities that are typically performed on an assigned frequency or cycle to slow deterioration. Some of those activities that typically fall under that category include flushing, sealing activities, and joint repair, joint maintenance. To be effective, these activities should be performed on some sort of a schedule or recommended frequency. For our performance measures, we decided to start with these four: flushing, crack sealing, and deck sealing is a part of that, poured joint sealing, and gland repair and replacement as our preventive maintenance performance measures. The top three for flushing, crack sealing, and poured joint sealing identify the percent completed on time for specific maintenance activities, and it's identified based on the recommended frequency. And those targets are set to 95%. The fourth performance measure is based on condition of expansion joints, and the goal is to keep those modular joints and strip seal joints in good and fair condition. I'll go through each one in a little bit more detail. First one is flushing. Our recommended frequency is flushing every year or as often as constraints allow. So the performance measure is looking at that percent of bridges that were flushed on time. We're looking at just state-owned bridges, and we do have some exclusions. We don't typically flush culverts unless they're historic. We also don't typically flush railroad bridges or pedestrian structures, and other exclusions include timber decks and bituminous wearing surfaces, which we don't have a lot of in our state-owned system. The target is currently set at 95%. Most of our outstate districts can meet that target, but constraints within our Minneapolis-St. Paul metro area, such as very high traffic volumes and access, preclude our metro district from hitting that target. In response to that, we looked at dividing that performance measure into different priorities and develop strategic goals to help place those resources where they might be most beneficial. Prioritizing flushing for bridges with joints, allow those bridges to function as designed. We're also cleaning out some of that debris that sometimes can puncture those glands and cause some of that leaking joint. It will also provide the crews an opportunity to assess those joints and schedule repairs as needed. For crack sealing, the recommended activity frequency is every 3 to 5 years, and that's based on a research project that we performed in 2014. So the performance measure is set at the percent of bridges crack sealed on time by square foot of deck area on a 5-year frequency, and that target is 95%. To identify that list of eligible bridges, we look at state-owned structures in good and fair condition that have a concrete wearing surface and have cracking, a certain level of cracking. So in Minnesota, we have an agency-defined element 810, which identifies the extent and severity of cracking. Then the sealing history in the SIMS maintenance module and our timesheet system is used to quantify that measure, to quantify the percent of lineal feet that were sealed on time. We also look at any contract work that may have been performed in that same category of work. And if there are any bridges that had a deck project within that window, then they would be excluded from that measure in that year. For poured joint sealing, the recommended frequency is typically every 5 years. A lot of times the crews will coordinate their activities so that they're crack sealing and poured joint sealing at the same time on the bridge. The performance measure for poured joints then would be the percent of lineal feet of poured joints sealed on time within that 5-year frequency and with a target of 95%. For poured joint sealing, the total list of eligible bridges is identified by querying the inventory for state-owned bridges in good and fair condition, where element 301 is at condition state 3 or CS3. We have defined some of our condition state language for bridge management elements in a certain way so that we can identify certain types of maintenance activities. And then it also allowed us to be able to query that data for these performance measures. So condition state 3, it's probably hard to read up there a little bit, but means that that joint has complete adhesion failure and needs to be resealed. Whereas a condition state 4 might require some sort of joint reconstruction or concrete work associated with that. It's a little bit easier to assign those repairs then. The measure then is calculated based on the sealing history in both the maintenance module and the timesheet system, plus any sealing that may have been done per contract maintenance work. Again, if there were any bridges with a deck project within that window, then they would be excluded from the measure. For expansion joints, you've noticed the last 3 we're really relying on that completed on time. For expansion joints, the frequency is more as needed, right? In response to an identified condition. There could be a torn gland, there could be a gland that's pulled out, there could be a joint that's too tight or too wide and it's not functioning as intended. And so we looked at this performance measure as more of a condition related performance measure. The goal is really to limit that percentage in severe and poor condition, as leaking joints can cause deterioration to those underlying elements. For this performance measure, again, for element, we utilize element 300. Because it's a bridge management element, we also had that opportunity to look at that language and modify it a little bit so that we could identify which type of repair might be needed based on that condition state. So for CS3, condition state 3 means that gland repair or replacement is required. And typically, if it's in an area that we can access, then we could send a crew out there to repair that gland or replace that gland or a section of that gland. For condition state 4, typically it's a more in-depth repair. You might need joint reconstruction or replacement, or perhaps there's concrete repair that's needed at that joint location. But it helps us then identify any joint that might be in CS4 would be a candidate for potentially a contract work. We looked at this similar to flushing. We could put this performance measure in tiers. So we could look at expansion joints in poor and severe condition or good and fair condition at that 95% level. Look at modular joints first as a priority. Second priority would be expansion joints located over pier, because again, when those expansion joints have deteriorated or are leaking, they can cause that accelerated damage to those underlying elements. And so it's more critical for us to really prioritize the repair on those elements. What are the next steps? We're reporting on these, so the preventive maintenance measures are all new. So we're reporting on these in 2022. We'll identify any of the performance gaps and costs that we might need to achieve those level of service A or those targets of 95%. To assist with achieving those targets, we're working on developing tools for the districts so that they can report those lists, or I should say track those lists, so to assist them with work planning based on condition data and preventive maintenance schedules. The key to this is data, right? And having good data to be able to report on this. So it's promoting that data tracking best practices to the districts as well. We're also working with Bentley to integrate a recurring maintenance tool within SIMS that will help us more automatically schedule these on a recurring basis. So once you set a task on a schedule, once you complete it, then it will automatically create a new task at the recommended frequency level. And that will help crews schedule these more efficiently rather than having to keep adding a task each time. We're also looking at implementing repair and programming strategies to reduce the expansion joints in poor and severe condition. Within our bridge management system review, it's allowing that opportunity to identify joints that are in poor and severe condition so that they can be programmed in a future or upcoming project. MnDOT also began working with Professor Bashak Bektas at Minnesota State Mankato to gather and analyze bridge maintenance data in conjunction with bridge condition history and also bridge characteristics to quantify that impact of maintenance and preservation. That research will hopefully help us identify if there's any additional performance measures, because by identifying the bridge maintenance activities that have the most benefit, then we'd like to measure that we're accomplishing those activities. As I mentioned previously, when we were talking about reactive maintenance, deck drainage systems is another one that we may look at targets and measures for, because they can cause significant pier cap and column damage. And we're also looking to finalize the bridge worker formula. Some of you may have heard me talk about that earlier. It is that mathematical method to determine or to calculate or quantify bridge maintenance staffing needs in terms of full-time equivalents. So it kind of all ties in, because to perform these types of maintenance activities, to meet these performance measures, we need resources, right? We need resources, we need labor hours, we need equipment, and there may be other options through contract or temporary workers to be able to hit these targets. Yeah, we typically each district typically performs their own traffic control, either with their bridge crews, or if needed, they pull in a maintenance crew, or perhaps in our metro district, it may be a separate traffic control crew. And we've asked when they track that maintenance that they're also tracking the traffic control under that same activity code, so that when we're looking at costs and identifying costs, it includes the traffic control component. In some cases, we do have to protect the drains when we're close to special waters of the state. We also are only allowed to do a high volume, low pressure flushing as part of our environmental guidelines.
Thank you, Sarah.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.